So we have an application problem that might involve these log equations. It's our review of our finance equations. So when you have a word problem, a couple things I want you guys to keep in mind. The first is task one is read the problem, of course, carefully. And while you're reading the problem, try to figure out which one of these three equations is appropriate for the situation. If you see the word compounded continuously, then we're definitely using this guy over here. If you don't see the word compounded at all, then we're using this equation over here, and if it's anything else, compounded quarterly or monthly or compounded daily, whatever, if it's compounded and not continuously, it's this excuse me, middle equation. So as I read this, we got a buddy Sally. She's putting this much money into an account that pays this % interest. She wants to triple her money. We want to know how long it'll take for the balance to triple. So if it's compounded, continuously. So I see this key phrase continuously. I know I'm using this formula. So I need to fill in 3 of these 4 unknowns. Keep in mind that this E is that constant 2.718-ish. It's a button on the calculator. But A, P, R, and T, those are all things like those are all variables. So as I read the problem again, we see that Sally deposits $5,500. That's the amount of money she's starting with, so that will be the principal. We see that the account pays 3.25%. That's a value for the rate, but of course I want to take that percentage and make it a decimal by moving this decimal spot 2 places to the left. So R is 0.0325. The question is how long will it take? So this is going to be our unknown. And then the amount is a kind of a hidden number, but she wants to triple her money. So if she put in 5,500, she wants 3 times that amount. I don't feel like doing that this early in the morning in my head. So it's 16,500 is the amount. 16,500. And now we're just going to plop these things into the formula. The amount equals the principal, e to the 0.0325 times that unknown. I'm going to keep that as a t. So I need to solve for this unknown. It's stuck up here in the exponent, which means at some point I will be flipping to log form. But before I could do that, I have to get this e to whatever to be by itself. This 5,500, it's got to go. And so this is a place where we are using PEMDAS in reverse. There's nothing to add or subtract, but this 5,500 is multiplying. So we're going to start by dividing both sides by 5,500. 5,500. These will cancel, and I just did this calculation. This divided by this will equal 3. E to the 0.0325t. My unknown is stuck up in the exponent, so I'm going to have to switch to log form. What's my base? Where does the exponent go? What's my base? Where does the exponent go? The base is e. I'm not going to write log base e. We don't do that. We'll just use the ln. So the natural log. The exponent goes on the other side of the equation. And then the 3 goes inside the natural log. There's no reason to use a change of base formula. I can just go ahead and use this button on the calculator. ln of 3 is some gross decimal. And then this disgusting number, which we're not going to round this right now. Like, I'll write it on my paper, 1.0986. Don't round it too much. 1.0986 equals this crazy thing. And now I'll divide this value by 0.0325 to get that t to be by itself. So, wow, 33.803 years. 33.803 years is the amount of time it'll take. So, read the problem one time, read it a second time, figure out which formula you're using first, and then go back through and read the problem and fill in those variables, and from there we're just applying all the skills we already have. Good luck.